What is a boiler? A boiler is a closed vessel that heats water to generate steam under pressure. This steam is a form of stored energy that can be used for various purposes on board ships. In simpler terms, you can think of a boiler as a large, sophisticated kettle. But instead of just boiling water, it creates high pressure steam, and this high pressure can be a potent force that can be harnessed to do useful work. Now, the question that you may ask is, how is this steam produced? Now, let's break that down into components. Component number one, fuel combustion. When we start to burn a fuel source, traditionally this was coal, but these days it's normally oil. This releases a tremendous amount of heat. Now that brings us to component number two, heat transfer. This heat that we get isn't directly applied to the water. Instead, it's transferred through the walls of the tubes or other specifically designed heating surfaces within the boiler. There are three ways this heat transfer occurs: conduction, convection, and radiation. Now, you have already studied these three modes of heat transfer when you were in school and college. But this we will keep in mind when we look at the boiler, and we'll touch upon that a little bit later on. Boiling point. As the water absorbs this heat, its temperature climbs up steadily. Eventually, it reaches at something called a boiling point, which is a critical point. This is where the magic happens, where water transforms into its gaseous state, and this gaseous state is called steam. Now, as more and more heat is applied, more and more water boils off, and it generates more steam. Because the boiler is a closed vessel, this accumulating steam causes pressure. Think of it like a pressure cooker in your house. The more steam, the higher the pressure. Now, let's delve into the fundamental principles that govern the boiler operation: heat and temperature. Heat is a form of energy. The energy associated with the motion of atoms and molecules. Temperature, on the other hand, is a measure of the intensity of this heat, or how fast these molecules are moving. The simple rule: add heat, the molecules move faster, increasing the temperature. Remove heat, they slow down, decreasing the temperature. When the temperature gets to minus 273 degrees Celsius, this is the point at which the molecules stop moving. This is 0 degree Kelvin. Now let's talk about pressure and its effects on the boiling point. The temperature at which the water boils is directly linked to the surrounding pressure. Under normal atmospheric pressure, the water boils at 100 degrees Celsius or 212 degree Fahrenheit. However, inside a boiler, we are dealing with much higher pressures. As the pressure increases, the boiling point also increases, thus allowing us to create steam at significantly higher temperatures, which we shall see is crucial for efficiency. Now, I told you that we will revisit the three primary mechanisms: conduction, convection, and radiation, that play a major role in the boiler. Conduction. The heat transfer is through direct contact. The heat from the hot metal walls of the boiler tubes is conducted directly to the water surrounding them. Convection. The heat is transferred through the movement of fluids. The hot gases from the furnace circulate around the boiler tubes, transferring heat as they flow. Similarly, the heated water inside the boiler also circulates, thereby distributing heat. Radiation. Here, the heat transfer is through electromagnetic waves. The intense heat of the furnace radiates energy, similar to how the sun heats the earth. And this radiant heat that we get from the boiler comes through as electromagnetic waves and is then absorbed by the boiler components. Combustion is the chemical reaction that releases the heat that we need. The fuel, which is either oil or coal, is combined with oxygen from the air in a very controlled manner in the furnace. This gives rise to a chemical reaction called an exothermic reaction, which releases a large amount of heat. The efficient combustion for this chemical reaction requires the right amount of air and the right amount of fuel and the proper mixing of these two. It also requires enough time for the fuel to burn completely. The cornerstone of boiler operation and all of physics is the first law of thermodynamics. Now, what is the first law of thermodynamics? It states that energy can neither be created nor be destroyed, but only transformed from one form to the other. Now, let me repeat. Energy can neither be created nor be destroyed, but only transformed. In a boiler, we are transforming the chemical energy of the fuel into heat energy, which is then transferred to the water to create steam. While some of the energy is invariably lost to the surroundings as waste heat, the total amount of energy in the system remains a constant. Now, let's talk about steam and very specifically two types of steam. The first one is called saturated steam. When the water boils, the steam produced is initially in contact with liquid water. And this is what we call saturated steam. Saturated steam has a very specific relationship between its pressure and temperature. If you know one, you can determine the other by using steam tables. Superheated steam. If we take saturated steam and then we heat it even further and it is out of contact with water, then we get superheated steam. Superheated steam has a higher temperature than saturated steam at the same pressure. It means that it contains more energy, which makes it more efficient for use in engines and turbines. Now, the question is, where is this steam used? Let's take example number one. Historically, large steam turbines were powered by high pressure superheated steam were used in ships and they were the main propulsion of these ships. So, steam was primarily used historically as main propulsion. But as we started getting diesel engines and they became more prevalent, the use of steam in propulsion reduced. So what do we use it for today? Now, steam plays a vital role on board ships in heating systems. It provides heating for fuel oil tanks, lube oil tanks, cargo tanks, and it's also used in heat exchangers. The steam that is produced on board is also used in domestic services, and if your ship has hotel services, for hot water, laundry, and even cooking. Though we don't directly use the steam from the boiler for cooking, it is used to heat up other services. So,